here we're given a relation. It's actually a function because this graph passes the vertical line test. There's no vertical line that crosses a graph in more than one place, so this is a function. And I labeled a few ordered pairs. There's negative 4, 8 for xy. There's negative 1, negative 2.5. Down below, the lowest point is 1, negative 4.5. Then we have 3, negative 2.5, and 5, 3.5. Okay, so it's a strange looking graph. I have some points on it. They want me to find part A, f of 1 and f of 5. Part B, the domain of the function f, because this is a picture of f. I should have said that. This is a picture of the function f. Part C, the range of f. And part D, for what values of x does f of x equal negative 2.5? Okay, so let's answer first part A. What is f of 1? Well, you know f of 1 is just equal to the y partner when x is equal to 1. Okay, so just look at the picture. What is the y partner in the ordered pair when x is equal to 1? I see an ordered pair 1, negative 4.5. So the y partner when x is equal to 1 is negative 4.5. Okay, well, what about f of 5? What are they asking for there? They're asking for the y partner when x is equal to 5. Well, look at the ordered pairs. When x is equal to 5, we have the ordered pair 5, 3.5. So the y partner is 3.5. See, this helps reiterate the fact that when you find the answer to f of a number, you're actually finding an ordered pair. Okay, part B, what is the domain? The domain of f? Well, that's going to be equal to all x values in the ordered pairs on that picture. Now, I only drew listed a few ordered pairs, but there's infinitely many ordered pairs. So you have to figure out, these are x values. They're the values that relate to the x-axis. And this is like a happy face parabola. It's opening to the left and right forever. It's got those arrows indicating that it keeps opening. So it's going to cover every real number x. So the answer for the domain of f is curly set bracket, all real numbers x, such that x equals any real number. Close your curly set bracket. That's set notation. Now, interval notation would be the smallest value, comma, to the largest value. That's going to be negative infinity, comma, to positive infinity for x values. And you'll notice I put round brackets on the ends. That's not because this is an ordered pair. It's not an ordered pair. It's an entire interval of x values. The open rounded brackets on negative infinity and positive infinity are only there because they are not real numbers, so they cannot actually be included in this set. Put a box around your answer for the domain. Part C, what is the range of f? Okay, now we're looking at all possible y values. Well, if you look at the picture, there's the smallest y value. The lowest y value is in the ordered pair xy equals 1, negative 4.5. The y coordinate there is negative 4.5. And then it moves upward, and every y value above that is somewhere located as a point on that graph. That means that the range, all possible y values, of the function f is equal to curly set bracket, all real numbers y such that y is greater than or equal to negative 4.5. Close your curly set bracket. You'll notice there's an equal portion in that inequality, guys, because it actually equals negative 4.5. All right, it actually touches negative 4.5. That's why there's an equal portion in that inequality greater than or equal. And the way you would write that set of y values in interval notation, you would list the smallest value first, negative 4.5, and put a boxy bracket on it because it is included. That's what that equal portion was telling us. And then the largest value for y is going to go all the way up to infinity, and infinities always get a rounded open bracket. Part D, they ask us to find for what value of x does f of x equal negative 2.5. So we're finding the x partner to y equals negative 2.5. So x partner to y equals negative 2.5. Okay, since we have an ordered pair, in the picture that's labeled as xy equals negative 1, negative 2.5, and we have 3, comma, negative 2.5. We have two ordered pairs. Oh my gosh. That means there are two x partners to y equals negative 2.5. Is that a problem for a function? Is it okay for a y to have more than one x partner in a function? Yes, it's okay. We don't care what the y does. We don't even check them out. It's just the x's that have to be faithful with only one y partner. So this is not a problem. It's just so clear to us that x equals negative 2.5 has two y partners. So the answer to the question are those two y partners. List them in curly set bracket, negative 1, comma, negative 3, curly set bracket. It's a positive 3, by the way. It's negative 1, comma, positive 3.